So last time we discussed complete evolution of from single command line application up until web services, and we went dive into the event serverless. So now what we are going to do is, this end it was like a command line application or a single instance application, and this end it was a totally high end, something like a serverless application, right? But we discussed from with the HTTP we went something called web services. In generally everything from this side to this side we call as a web services. Okay, why? It is operating on a web in the sense mainly HTTP protocol, but that doesn't limit to HTTP protocol. So anyway, these are fall into two categories, RMI and RPC, right? RMI mean a remote method invocation, RPC mean a remote procedure call. So RMI mainly go with the Java, right? RPC is a kind of a generic way, but RMI mainly came up with the Java, how Java handle things. But what we are going to do is, we are going to deep dive into web services and see how you can correctly write a web service. Because if you get any software engineer nowadays, they can write a REST service. Maybe they use Nest, maybe they use Express, maybe they use Spring Boot, they write web services. But when code reviews, 98% almost, my experience is they are doing it wrong. Either naming convention wrong, either their practice is wrong, either they did stick to some sort of a principle it explaining. Okay? It's wrong. So always in a project, if I go for a code review, if they have a REST services, it end up with teaching them how to do a REST service. Okay? But before we go into the REST, we need to see how this initially came up. So now I am not going to that side because we discussed what we wanted. There is a server, the server running a container running a service, and the service exposed to outside, and then it starts to work. So now mainly these services, initially we discussed start with the SOAP, right? SOAP is a simple protocol to exchange the messages. SOAP has a dedicated way of working, because SOAPs, like for example, you can think of, I don't know whether you guys did it or you experienced this. So you can, like we used to do for pen friends, we send letters and we receive letters, right? So when you send a letter, what we do is we write a letter and put into envelope and put the stamp and then say where it to and where it's from. Okay? So based on the person you are sending, you have like athing, athata, veting, veta. There's some cute things people do. So now, what this mean? This is the where is the destination. In case if you fail to deliver, come back to here. Okay? So this is the one it's attesting. Okay. So this is paid, valid letter to send. SOAP mimic exact concept. Right? In a SOAP, we use something called SOAP envelope. It's like this. Okay? And then you have SOAP security to authenticate the messages. And then you have a destination. And then you have a fault mechanism, fault handling mechanism. Right? So SOAP almost mimic this one. Right? So now don't go deeper saying, okay, who is the postman and who is the post office and so and so. But that's why they even use that SOAP envelope concept. You get the message, put into envelope, and then you send it. Okay? So that's a SOAP. SOAP is mainly XML based. Right? SOAP is mainly XML based. What I have seen is when people really don't understand the SOAP and how SOAP is supposed to work, they treat SOAP as REST messages. It's wrong. Okay? SOAP mean to be a synchronous protocol, right? When I say mean to be, there are customizations sometimes people do in implementation, as I said. So now, when a SOAP message, you know what is synchronous and asynchronous? Huh? What? You know the Bob and Alice? Bob and Alice? No? You don't know Bob and Alice? There are two people called Bob and Alice. They sacrificed their entire life for software engineering undergraduates. You don't know that? Her friend. You don't know really Bob and Alice? You never heard? There's a guy, two gentlemen called, not gentlemen, lady and guy, Bob and Alice. They sacrifice, they're a couple, right? They sacrificed their entire life, their entire romantic life to for software engineering undergraduates, especially undergraduates. Why? Because Bob and Alice used to send the messages each other. Bob sent the message, Alice reply, Alice send the message, Bob reply. So they never get married. Why? When they get married, they stop communicating. So they didn't get married. He took it very serious. When you learn security, SSL and stuff, it is not that Bob sent the message and Bob sent the message to Alice. Learn the Bob and Alice. Pau netta. Have you heard Romeo and Juliet? Huh? Sali Ashokamala? Huh? Jack and Rose? Huh? Ah. Okay, so SOAP mean to be synchronous protocol. So that means, as a result, what happens is it's a overhead. So now just assume there's a small clothing store, right? 50 Alice's going. So now 50 Bobs are also going and hanging around. It's loaded, overloaded in a synchronous manner. Right? Only 50% is the capacity. So now they're hanging around their girlfriend. Right? So now if it is asynchronous, what happens is you go, you drop them, and then you come back and collect it. Okay? So initially SOAP was okay. That's fine. Because something is better than nothing. Right? When there is nothing, something is better. So this was the first game. This was really good. And then here they had a concept called discovery. Right? You have a discovery. And there is a server who processes the and there is a requester. Right? Request first discover about the service and then only can invoke the service. Right? So when something is changed about the service, it updates the discovery. Right? We use a WSDL. Right? WSDL, WSDL, Web Service Definition Language. Right? So when you use a web service, right, if you happen to fall into some old project, have some old technologies, then you figure out WSDL. Even when we start the Rapid, when we talk to M3 exposing SOAP APIs. Okay? When this dev team start to develop, all those millennium dev team, they were stuck. What is SOAP? We cannot call in a postman. It doesn't work, right? Because SOAP is a different animal. So you need to you have a tool called SOAP UI. Okay? SOAP UI. The weird part is SOAP UI can do the REST call. Okay? But usually as you use the postman, yesterday you learn another tool. What? Yesterday you learned another tool. Okay? So SOAP UI is a SOAP. I'm not going to dig much into the SOAP, but you need to read about it, how the SOAP works, and what is the WSDL, and see some example WSDL files. And if you want, try to create a SOAP service. Okay? It's not must, but it's better to have a your hand little dirty to work with the SOAP services. And hosting SOAP service little bit painful thing you to do, but just try, just give a try. Painful thing is not hard, but you need to download some sort of servers and then create this one and create a EAR package and then you post this in the application server, but it's good. You're good to learn. So now, like in summary, SOAP is some, you know JDBC, right? JDBC, what we use in our program, if we need to fetch the data from a database, we use the JDBC. It's the same way we use SOAP to fetch some information from a remote service. Okay? Now, when people were living with the SOAP, there was no problem. Software engineers know how to write a SOAP service, and there are frameworks emerge, and everything was going good. In around 2000, and I don't remember the exact year, the guy called Roy Fielder, he posted in his PhD thesis saying there is a better way to communicate services than writing a SOAP services. Right? It was his PhD thesis. He said, look, SOAP has this problem. Why we don't do this one? Okay? So that is called REST. Representation State Transfer. REST is an architecture. It's not a protocol. We discussed in one of our last session difference between architecture and protocol. If it's a protocol, it's a set of rules. If it's architecture, you can customize. Okay? What he came up with saying, he said, we don't have to have this type of a governing mechanism like having an envelope and having the servers to process and so and so. Why we don't have some sort of architecture where you have object has a state, and we communicate this state over HTTP. Okay? Now, SOAP is a synchronous protocol. REST mean to be an asynchronous architecture. REST is mean to be an asynchronous architecture. Now, REST is an architecture. You need the transport mechanism. Right? What the REST says? There is object has a state, and we transfer the state to this side. We communicate the state. It doesn't tell you must do this using HTTP. You can find a transport. Right? So now you want to bring something from remote. You define, it has to put in a box, right? Box has to be sealed, write on the box and handle with KR or something like that, right? And then you can define the transport, whether you take this through a motorbike or a three-wheeler or a van, car, you can define how you transport. REST has that feature, right? But mainly REST use HTTP as a medium to transport. HTTP as a medium for transport. Right? Now, SOAP is asynchronous, REST is meant to be asynchronous. However, HTTP is a synchronous protocol. HTTP is not an asynchronous protocol. HTTP is a synchronous protocol. So that means if you send the request, it waits to get the response. Right? It waits to get the response. It is not that you send the request and response come back later and you can go and pick up later. Unless you design that way, HTTP is a request response life cycle. Now you build asynchronous architecture on top of a synchronous protocol. What's going to happen? This entire architecture become synchronous again. Okay? when software engineers come to, not in your level, even senior engineers, tech leads, come and explain, okay, so we have a REST architecture. Why? Because we need to have a asynchronous behavior for our system. Okay, how those REST services are communicate? They use HTTP. So now it's asynchronous? Yeah, REST is asynchronous. Yeah, REST is meant to be asynchronous. But the problem is the way you implement it, forcing it to be synchronous. Okay? How HTTP works, we are going to little deep dive into later on for a HTTP. HTTP works is in a client server model. Right? So now, let's say I call you. I am the caller, you are the receiver. Right? I am the caller, you are the receiver because I called you. Now you call me. Now what happened? You are the caller, I am the receiver. So how HTTP works is like that. Right? So how HTTP works is like that. So if this person is initiating the request, it becomes a client. And then this becomes the server. What happens is initially client send the hello. Right? It's a hello. Right? Then this is going to act to this one, and then there is a negotiation going between. We say I am not go that level because we have a different day. We are going to deep dive into HTTP and TCP, how this works. Okay, so I am not going to take it here now. So, but eventually works is if when you get the HTTP 1.1, right? HTTP 1.1, not the 1.0, 1.1. What happens is you open the connection, you send the messages, and then later on the connection getting closed. HTTP 1.0, what happened? You open the connection, send the message, get the response, close the connection. Open the connection, send the message, get the response, close the connection. Each time you send the message, you open a connection. If the opening a connection taking 10 milliseconds, right? Then when you send the 100 requests, it takes 1000 milliseconds, which is a 1 second. 1 second delay. To avoid that, HTTP 1.1, what they did, they made, okay, you open the connection and then you can send the messages, then you close the connection later on. Right? For that, we are using some special header called keep alive. Okay, again, I am taking what we need for this one, right? That's it. So keep alive. So now the header is, the connection is still alive. At some point, when the server want to close the connection, right, it send TCP header, not HTTP header, fin header to this side saying I am going to close the connection. So then connection become half duplex, right? So now in this model what happens is you send the request and then you get the response, right? The only difference is you can send the multiple requests without waiting for response. You can do it. Okay? Because you don't need to open a connection. So now it looks like asynchronous behavior. Because you don't wait the response, you send the connection. But here's the catch. The server responding to you in the same mode it received the request. Right? So let's say this request take 100 milliseconds to process. This request take 50 milliseconds. This request take 30 milliseconds. This request takes 2 milliseconds. Right? If this request reach to the server little bit later than this one, then still this has to wait until this one is dispatched. If it's the same connection. Right? So this is not exactly how it is, but we are going to deep dive into this and learn it. So later on. So then we will see exactly how this each request being processed and how the response come and where these guys waiting until that happen. Right? So what I want to understand, this is worked as a synchronous behavior. Right? It is not asynchronous behavior. So you build in something asynchronous on top of the HTTP, then your whole system become synchronous again. ROW is this REST architecture, REST guideline stays on top of 6 different pillars. Right? It has 6 different guidelines. Again, these are guidelines, not rules. if it is a valid proper REST service, right. So, number one, he says you have to have a uniform interface. What does uniform interface mean? In a simple term, if you, let's say you are a developer, you come to work on Brandex and then you are working our APIs. Once you worked on one or two modules, you should be able to like guess how, if when you go to a different module, you should be able to guess how this API works. It's a uniform across the board. Naming conventions, how the resource being called, right? Okay, so for a create, we use a post, only post. We never use something other than the post. So now you're familiar with it, right? And the naming convention, how you address the resources. We are going to learn it a little later. How you address the resources. That is uniform interface. When you work on a solution, when a developer work on a solution for one or two module, he should be able to understand how the rest of things works, right? So best API designed to match this is a Facebook API, Facebook Graph API, right? So if you work on like 2-3 APIs, you can guess the rest. It's very easy to guess. For example, they have endpoint called me. It tells about everything about the token owner, right? Then if say me/friends, it return you my friends, right? If I say me/friends ID, it tells his profile. Me/friend/friend ID/messages, it's give its, see now I can like in memory I can tell how the API endpoint goes. Without seeing the document, I can kind of guess and work on API. So that's a uniform interface, right? So every API is designed in a way that can, but SOAP didn't have it. Because SOAP is like, because it's we call in the remote procedure, so it depends on how they have written it. Okay. The second one is, I don't remember the order, right? Client server. Right? I'll share the link to his PhD thesis, so you can go and like read it. All right, when you have free time. If you have, when you have free time, read it. So it's quite good. Actually, not easy to read, but quite good, right? So client server model, what the client server mean, so you have you hosting your server logics and everything on the server side, right, on a different server, and then you have a client where client not necessarily too aware about the business logic. Okay, client can invoke the server's business logic and get the results and produce it, right? That's a client server. The client server architecture is, then whoever hold in the business logic become the server, right? Whoever the hold in the business logic becomes server. Client is invoking it. We don't write business logic on the client side. Okay, that's a client server. And then third one is layered architecture. Layered architecture mean you may have multiple servers. Layered architecture has a different meaning based on the context, right? When you go inside the service, you have a different layered architecture, right? In here, what the layered mean, you can have a business logic, the service run on one server, your database stored on a different server, your authentication logic handled on a different server. Likewise, you can segregate each part, right? You can segregate each part for a different servers, different layers. You can say different layers, right? But when you come to layered architecture for a microservice level, it's different. When you come to a layered architecture in a EJB kind of a thing, it's different. But here it means this, right? So uniform interface, client server, layered architecture. Layered architecture mean multiple layers to handle. Okay? And the fourth one is cacheable. Right? What the cacheable mean, sometime based on the situation you can cache your object status. What we did, we had object has a status and then we transfer the state. Okay? It is not always necessary you go back and check the object status from the source. You can cache it. But caching can come in a different layers. Your caching can come in HTTP layer, HTTP caching, response caching, right? Or you can use something like a different caching mechanism like Redis or a Memcache or something like that. What it says, it's a cacheable, right? It's a cacheable. Keep the fifth one. The sixth one is code on demand. But this is kind of now we consider as optional and we say stay away from that. What the code on demand mean, you send a request, you get the response is executable. Okay? You know the JSON, right? You know Jason? Where he lives? You know this JSON? Huh? What stand for? JavaScript object notation, right? So JSON, they came up with something called JSON P. What it does is, the response itself is executable. Okay? But this was not popular. Right? We start to not to use it. Why? Because if the server producing the response is compromised, then they can manipulate the client. Why? Client take this response and blindly execute it. Right? Client take this response and blindly execute it. So therefore, this is we are not using. Now, most important part of this, at least for me, when I am taking this forward, is called stateless. Right? Stateless. What stateless mean in Roy's thesis, what he says, server shall not keep anything related to the request. Okay? So have you seen any legal agreements? It doesn't say, it keep using shall. So that means you shall do it. Right? So it says server shall not respond. So that's why it's an architecture. You can store if you want. But he says don't do it. Okay? Don't do it. For example, let's think something like this. Right? So now we have a shopping cart website. Right? We have a shopping cart website. She come to this shopping cart and then she buy some items. Now these items, she added like 25 items to her cart. Now she come in another place or other city or other where they don't know each other. She is also adding some other 50 items to the cart. Okay? So now we maintain this on a server side, probably in a caching server. Right? Caching server. So now we have because this is a very rich system, we have a 3 different node to do these things. Okay? 3 different nodes. So redundancy and reliability, scalability, everything is in place. Now we stood, suddenly this server crashed. And let's assume this is in memory, server in memory, the server crashed. Now next time when she refreshed the cart, when she added the 26th item, all 25 items are gone. Why? Those were in the memory. Right? And then she lost her all 50 items. Now they need to add it back. Right? If I was the user, I never go to that site again. Why? Because every time they have a server crash, I need to add my items. Right? Because it's a It's a simple fundamental. Why server doesn't know where's my item? Now, the solution is you can have like kind of a state server across all the services, expensive, but you can, right? So then server don't keep it in server side, server keep it in a state server, like a Redis or a fast in-memory server, and then you can do it. But Redis also can crash, right? When you cache something, you need to make sure system can live without the cache. Fundamental mistake software engineers does, the moment we allow them to use a Redis or a cache, they put everything in the cache, right? Sometimes there are systems, only mom and dad is not there. Everything else inside the cache. That's wrong. When the cache restart or cache crash, then your system is gone. When you put something to the cache, you need to make sure system can live without it. When the cache absent, system should intelligent enough to fill the cache back and keep moving. We are going to discuss separate session on the caching patterns, right? There, I'll keep it for that one, but for now, this. So now what Roy suggesting is, don't server take the responsibility of managing this, keep that to the client. Okay? Client managing what is the state of the connection. Alright? That doesn't mean you should keep all the items in the client, and now you have a different question. Now, okay, now client can change the pricing and kind of go to local storage, change the pricing and resubmit and things. So, right? It is not the point. The point is client should, don't apply to this example, the client should manage the connection state. It can be a cookie, or it can be some sort of something stored in the local storage on the browser, right? So then browser crashed, its service okay. But nowadays what we do is we use distributed state servers and things to handle this type of scenarios. We don't even give the load to the client, but that is what his initial suggestion, right? Server don't handle state. So that means, let's say you are filling a wizard, right? It has 3 pages, right? 1, 2, 3. When the first page fill, when the second page comes, it is not necessary server aware the last page came like 30 minutes ago. It's not necessary server to aware that, right? So you need to design in a way that each submission treats separately. So this is the most important part of this, right? Which is called naming convention. How you name resources. Okay? Now we learn in REST what we are dealing with objects. The objects or the resource we have, not the object, we can say resource. Resource on the server side. So we have the resource and we are going to represent the state of the resource. Okay? So we may create resource, we may delete resource, we may update the resource, whatever the resource. The first rule you need to understand, use nouns as much as possible. Okay? Use nouns. And also make it plural. Why? Because, for example, okay, for this example, we are going to take, because we have a URL, first you have to have a URL. Right? Usual pattern is URL in the sense, sorry, we'll say host name, host URL, service, and then only your name is going, right? So in our example, let's say this part A is https api.codelabs.lk. So that is this path. We don't have a specific port, and the service name is vehicle management, or let's say vehicle service or something like that. It's a primarily based, let's say vehicle service, right? From here onwards only we are going to consider. Okay, so in the next things I'm not going to write this part. So you need to understand this is coming from here. So now vehicle is our class. If you picture the system, vehicle is our class, right? But we don't keep the vehicle in the system. We have multiple vehicles. So always URL goes with the vehicles. Okay, vehicles, right? And when you in this one, when you do this one, it will return you all the vehicles you have. Okay, it will return you all the vehicles you have. And if you pass like this, vehicles something like this, then it return this particular vehicle. Okay, then it return this particular vehicle. Vehicles, this one. What here we are saying, out of the vehicles, give me this. Right? Out of these vehicles, give me this. Right? So rule number 1, use nouns as much as possible and use plurals. Employee service. Okay? I want to return all the employees. What should be the endpoint? What should be the endpoint? Employees. Right? Employees. I want to get his information. His employee ID is 7530. Then how will I do? Employees 7530. Right? Now I need to see all the projects he is working on. Employees 7530 projects. Now this return 10 projects, right? I have a project called P008. I need to get the information about that project. How I do? 7530 projects P008. You got it. But if you go for a code review, what I usually say is employee service / get employees. They took the method name into the URL, which is SOAP practice. Because SOAP is a remote method, right? So you pass the method name inside the SOAP envelope saying action is this, not the action. Something, I don't remember the property, that's the property name. You can pass the method name in the property name. So when this goes to the server, server knows, okay, he is asking to execute this method what I have. But REST is not meant to do that. You don't expose your method name and anything to the outside. So I have seen enough, say get employees. Now this method goes as a get employee by ID. That's how this goes, okay? This usually they written get employee by ID equal 7530. That's how, this is completely wrong. This is completely wrong. You are not addressing the resource. Okay? Understand? Right. So now, I want to know duration of this particular project. Right? I want to know duration of project. So here, now you don't say durations. Why? Project don't have multiple durations. So then project duration. So that how this goes is, now you will see, okay, how I can figure it out. This is how it goes, right? So this is how it goes. So this goes, if you take this, just picture this is in your system, you have maintained this employee service. So you have a project class, right? Project class. Here there are two type of things, no? One are properties, name, ID. Duration is a one of a property, right? If this project is in multiple locations, then what they have? Locations, then they have an object, probably array, ID 1, location Colombo, ID 2, something like that. So if I want to get the project locations, it will say P008 locations, right? P008 locations. But when I get the duration, it's just duration. Why? Because it's a property. If it is a collection, then you go plural, right? Main one obviously is a collection. Now I want to get this. So now here I want to get his active projects. Now from this URL here I want to get his active projects. How I can do it? How I can do it? How I can do it? Employees 7530 projects. How I can do it? Shall I pass as a 7530 active projects? Then what? Huh? Projects active. Okay. Any other ideas? So here is the rule. If your resource addressable by the value you pass here, then it's a path parameter, right? He's right. Why? Because status is not something addressable. It is not the key of your resource. So then it goes as a query parameter. Okay? Then it goes as query parameter. It goes 7530 projects status equal active. Status equal active. Okay, what is the rule? If your resource is addressable by what we passing here, then it's a path parameter. If you want to get the bunch of resources but you need to filter out, if you need to use a filter, then it's a query parameter.
So okay to expose the ID, project ID in the URL?
Yeah, it's totally fine. Nothing wrong. There are some people taking security in a weird way. Okay? I have experienced sometime people thinking, seeing the domain name DNS is a security threat, right? So it is as designed. Your security should put saying, okay, I don't let you to come in, right? So it is not that exposing your address is bad or where you live is bad. It is about how you protecting yourself, right? So you close the door at home, right? By hiding where you are doesn't protect you. So likewise, telling what's your project ID or something, it's not a big deal. Usually these IDs are domain insensitive. That's how you usually put the IDs. Usually UUIDs or something. Sometimes you feel like, because if you use something, anyway, what you need to think is, you are sending the data over the wire, right? So because you are seeing it obviously because you have access to the data, right? Server seeing it because server knows the data. But the problem is if someone is in the middle, can read the data or alter the data. So there is a transport level mechanism, security mechanism you need to enforce to avoid that. Not that you are not sending it. Okay. So like as long as you stay home, you don't have a threat. But if you get into the road, some vehicle come and hit you. But you need to take a security measurement to not to happen that. So staying at home is not a solution. Okay. So there are few types, different types of resources we are talking about. One is a document resource. Document resource is something like what we discussed, employees, employee ID, that give you a single document about employee, right? So that is a document type of resource. For example, employees, right, E0010, right, that give you single document. Store mean sometime you may store a list inside the document, something like a wish list. Right? So you have one document, but inside that you have list. Okay? So you have multiple wish list, say wish list, home need. Inside this one, this is a single document, but what you have, nature of the document is to have a collection. Right? Your song playlist is a single document, but inside that there is a reference to multiple other documents. Right? The collection is the other side of it. Right? You have the collection itself like employees. Employees is as a collection. So collection is that. So it is a other side like employees. We discuss employees, E010, projects. So this is a collection. Right? Other one is a controller. This is the only time you use something verb on a URL. For example, checkout. Right? So bags, bag ID, checkout. You can give a URL like that. That's not wrong. So don't have to say, okay, so we only should put noun on the URL, right? Right? So now you kind of somehow mapping this checkout into this thing. No, you don't have to do it. It's allowed. Right? Controller, the URL. When you take the photos of this board, are you like really converting in the note and you have a bunch of photos in your photo gallery? If you have a bunch of photos in your photo gallery, in 1 week later you will not be able to figure it out what this is. We are going to discuss few best practices when you do in a URL. Okay? So you will find sometime, because of technical reasons, these best practices sometimes is violating, but you have to have a really good reason if you want to violate it. So now let's say in our previous example, so let's write all those things later on, and then employees E010. Okay, E010. So adding another ending with this resource with the / is wrong. Why? / is mean to tell the hierarchy. Right? So this E010 is a document type resource. It is ending there. It is ending there. So you should not ending with the tailing slashes, tailing / okay, because it's ending there. Right? And that's number one. Number two, when you need to use two different words in your URL, use hyphen but not the underscores. Right? For example, costing service is a bad one. The correct one is costing service. Okay? So why Because sometime when we documenting, let's say you put this URL in a document, this become a hyperlink. Document has a trend of underlying the hyperlinks, right? Now when you underline this one, this is how document shows you, okay, right? So now when you read it, you think, okay, costing space service, because your underscore is masked by the underline, right? So don't write that, use a hyphen when you have a separate words. Always use simple letters on URL, right? Third one, always use simple letters on URL, right? For example, employees E001 project is a bad, right? Just because of its a name or something, it's not necessarily to make it caps, right? It doesn't matter leading, ending somewhere, you always use. If you have a something like a cap is required, use some different technique where use a hyphen to separate or something like that, because when you use the camel case only, this become a problem, right? For example, this is the wrong one, but if you want to say active employees, this cannot come in the URL, don't take this as it is, right? Employees, right? Then don't make this, because if you write this like this, active employee, no one can read it, because it goes as a single word. That's why you do this camel case thing. So what you can do is use a hyphen here, okay, something like that. So don't use a capital letters on the URL, use always simple letters. Another thing is, fourth one is, do not ever use extensions on the URL. That I have seen these people doing, I don't know why they do it. It's like this, employees E001.html. You don't have to do it, because server tells you what is the content it's rendering back, right? You don't have to do it. Don't use extensions on this one.
For the resources, can we use
Hmm?
for the resources, like .pdf?
Yeah. If it is that is not coming in the URL, the rest service, no. So that is the resources we are coming from the storage. That is fine. So his question is like, sometime, let's say you are downloading a PDF or some sort of a movie or something, then what we do? So that is fine, because that is the REST response we are coming. We are accessing the file storage content. And other 5 and 6 we already discussed, right? One is, do not use CRUD operations on URL. Get employee, create employee, those type of things, right? Do not use CRUD operations on URL, right? And the sixth one is, use query parameters to filter and path parameters to identifiable resource, okay, identifiable resource. Now these are on the URL and the response. HTTP use something called status code to tell the server, can tell you what has happened, right? Server can tell you what has happened. So that is telling you through the status code. So if you're working in the REST services, it's very important to respect to the status code, because status code tells you without going deeper what exactly has happened. The status code has few kind of a series, right? 100 series and 200 series, 300 series, 400 series and 500 series. Okay? So as far as status code concerned, who's telling the status code? Client or the server? Server. So we need to see this server's point of view, status code, okay, not client point of view. So 100 series is used to do information messages. For example, let's say she is the client, I am the server, web server. She is saying when the hello initiating, she says I want to upgrade to WebSocket. I want to upgrade to WebSocket. I send response to her saying 101 protocol switching. That is the information message, right? The clients are aware about this. We are transferring information. There is no body. There can be a body, but the mean to be information. 200 series mean success, right? Always not necessary 200 to send in a response. Many software engineers doing this mistake. They always in the 200. When I say why 200, no, it's success. No. There is a series of status code you to use, not just one. For example, let's say something like this. I am the server, right? You are the client. You giving me a batch job to process. I have to process 10,000 of records. What you do is, you give it to me and I will run this batch job at midnight. You submit the job. Can I say 200? No, because I don't know what is going to happen to the batch job. It may fail. Alright? I am going to tell you, accept it. Right? I am going to say accept it. Accept it, I accept the job. But I don't know what's going to happen. Okay? So it's required you to have right status code, created, accepted, no content. There are so many status codes are there. Right? 300 series mean this is success. This info. 300 series mean redirection. Okay, redirection. So I am sitting here. You come and ask, hey, can I meet Kehliya? I said no. He's on upstairs. You redirect. There are two redirects, permanent redirects and temporary redirects. If he is today moved to somewhere, I said okay, today he is there. Or he is now not coming to here, he is in a different office, I would say now he is not here, he is in that office. Right? So there are so many URL for that also, 304, 567, each has a different meanings. 400 series mean client side errors. That means, so these are in the server's point of view, no? Right? Server. So client side errors. Client made something wrong. Okay? Client made something wrong. 500 series mean I messed up. Server side errors. Right? Server side errors. So usually we say this something like this, right? So this is a high 100 series, okay? 100 series is high. 200 series is I'm good, right? 200 series is I'm good. 300 series is go away. It's getting angry. Go away. 400 series is you F stars up. 500 series is I F stars up. That's the easiest way to remember it.
In the beginning, we looked at it. Now REST is supposed to be asynchronous. So if we use HTTP, it becomes sort of
Synchronous.
So is HTTP the only way that?
No. We are going to discuss about the messaging. Okay. The REST is architecture. As long as REST implemented use this as a transportation, then HTTP as a transportation, then it become a synchronous, right? So we are going to learn how we make it really asynchronous. That's what we do in the event-driven architectures. So we can use a JMS or a sort of a messaging system where then it make really asynchronous.
Then this status code is not relevant to.
Then status code not relevant. Status codes are tied up with the HTTP, right? So then status code doesn't matter. It is not there. Here is their favorite assignment. Okay? You need to come up with in memory 10 different status code. 10 mean 5 in each ne කොහොමද කරේ? Yeah, status code 5 on each, right? Okay, so you need to 5 on each නේද? Yeah? Total 5? Total 10. Madin. No, headers separately. Okay. So since we didn't cover the headers yet, right? So what you need to do is you need to come up with 10 uncommon status codes. Uncommon mean you cannot come with the 200, 201, 202, 203, 204. Those are like very common, created, no content and so and so. 307, 308, not 404, not found, not valid. Right? 400 bad requests, not valid. 500 internal server error, not valid. Right? 502 bad gateway, not valid. 503 downstream services unavailable, not valid. Okay? 504 is the same. Right? Those are not valid. 10 uncommon status code. Right? Remember this. Right? Some people, how they do is 204, no content. No, not like that. I need you to tell me what it mean and when to use it. I don't need you to come and say 400 bad requests, 404 not found, and so and so. Right? So I'm going to tell you, you need to aware when to use, what type of scenario, what are the criteria to use, and what does it really mean. Okay? 10 different status code. You can pick, you have 5 different series. You can pick anyone, any 10 different with the use case and the meaning. Okay? So better to have a 15 in hand, because if someone else tell your one before that, then it's not valid for you. Okay? Right? So better to have a 5 backup codes. Okay? Right, good. I'll talk to you tomorrow.